Hello everyone, welcome to homework 9. This is going to be the first part of completing the square. I'm actually really excited about teaching this because I've never taught it before. So let's jump right in. You're going to need this in your pre-calculus class during your conic sections. So whenever you are graphing circles, ellipse, hyperbola, and parabola, you're going to need completing the square. Now, what completing the square is technically used for is solving quadratics. You should have already learned 3 ways to solve quadratics in your pre-calculus class. You can solve quadratics by graphing. So where is it crossing the x-axis? You can solve quadratics by factoring, which we did the last 2 weeks. But not everything is factorable, right? And not everything lands perfectly on a 3 or a -3 and a 3. Sometimes you get 2 plus square root 5, and that's not exactly a pretty number. So when you can't factor and it doesn't land perfectly on the graph, you should have just learned your quadratic formula, right? Which is your negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's 1, 2, 3 ways to solve quadratics. Completing the square is another way of solving quadratics, just like these 3 ways are. So that is technically what this is used for. However, you are going to need it, like I said, in the conic sections. And so what we do today, you're going to need, but we're actually going to be taking this a step further today because we're solving. You're not actually going to be solving when you use this in your pre-calculus class. You're going to be using it to rewrite your circles, ellipses, hyperbolas, and parabolas in a certain form. Okay, so we're actually going to take this a step further than what you are going to need. Okay, after all saying that, let's get started. So you have a square root property. And if you have something squared, all you do is you take the square root of both sides and you get plus or minus whatever that square root is. And when you did quadratics, you should have also learned that as well. The big thing with that one is whatever that squared term is, what you are needing to do is isolate that squared term. And then it just kind of gives you this little helpful hint right here that we're going to use that plus or minus notation. So when you have plus or minus 3, that reads as plus or minus 3, and it's a shorthand for 2 answers, right? That means positive 3 as well as negative 3. So here on example A, you got x squared equals 100. Well, that squared term is isolated. Excuse me. So take the square root of both sides. The square root of x squared is x. And then we get the plus or minus of square root 100. Well, the square root of 100 is 10. So my answer is plus or minus 10. Right, and what that means is x could equal 10 and negative 10. Now, if you were doing your homework in this class last 2 weeks, and hopefully you were, we solved this by factoring, right? If you have x squared equals 100, we would move that 100 over. We'd have x squared minus 100 equals 0. Then this was a difference of squares. So this factored to x plus 10, x minus 10. And then when you set each thing equal to 0, you still get your plus or minus answer just like we did. So this is just a different way of solving something we've already been solving. Much quicker though, right? Okay, same thing on B. We've got x squared minus 50 equals 0. So you need to isolate your squared term. So I'm going to add my 50 over. So we've got x squared equals 50. And so now that that is isolated, take the square root of both sides. So this becomes x equals, right, because your square root and your squared cancel each other, plus or minus, and I'm going to go ahead and skip a step and rewrite the square root of 50 as 25 times 2, right? I should have read the instructions, but it says simplify your answer, and we can simplify. So this goes back to homework 3, I believe anyways. Nope, homework 4, where we're simplifying radicals. I'm figuring out what my biggest perfect square is, which is 25. So this becomes x equals plus or minus the square root of 25 is 5, and then that stays a square root 2. Okay, and you can also, I'm going to be doing it this way because it's a lot quicker and a lot shorter. But if you don't like that, the other way to do that was to break down the tree. So you could say 5 and 10, 2 and 5. Your pair of 5s come out, your 2 stays inside. Okay, so if you don't like your perfect squares, that's the other way to do this. Okay, C, same thing. Isolate that squared term. So we need to move that 30 over. So add it over to get 2x squared equals 30. Divide both sides by 2. So I'm going to get x squared equals 15. So my x squared is isolated now. So take the square root of both sides. And I get x equals plus or minus 15 is only 5 and 3. That's the only way to break it down. So we don't have a pair of anything. And so this stays as plus or minus square root 15. Now D looks different, but really it's very similar to part A. You have your squared term already here isolated. So we can jump right into taking the square root. So when I take the square root of both sides, my square root and square cancel out here. I am left with x plus 1. Okay, equals plus or minus. I'm going to rewrite the square root of 12. The biggest perfect square that goes in is 4. So 4 times 3. So I've got x plus 1 equals plus or minus 2 square root 3. Square root of 4 is 2. And then your last step is to move that 1 over. So you can write this as x equals plus or minus 2 square root 3 minus 1. I don't know why, but I prefer that plus or minus in the back. So I'm going to be writing all of my answers and this negative 1 and then plus or minus 2 square root 3. I don't know if I like that more because that's usually what your answers look like when you do the quadratic formula, but that just looks better in my head. Okay, so same thing on E. Is your squared term isolated? Yes, it is. So take the square root of both sides. So your square root and square cancel. So I'm left with x minus 5 equals plus or minus the square root of 7. Doesn't simplify, that's a prime number. And then your last step is to add that 5 over. And so I'm going to get x equals 5 plus or minus the square root of 7. And then lastly on F, is your square term isolated? In this case it is not. So add your 20 over. And so I get x plus 3 quantity squared equals 20. Now my squared term is isolated. So take the square root. This becomes x plus 3 equals plus or minus. 4 is the biggest perfect square that divides in. So 4 times 5. So I've got x plus 3 equals plus or minus 2 square root 5. And then my last step is to subtract my 3. So my final answer is x equals negative 3 plus or minus the square root of 5. Plus or minus 2 square root 5, sorry. Okay, so for the most part, this should be a review. Like I said, when you did Quadratic Formula, I believe, you did problems like A and B. You may have not done problems like D, E, and F, but these 3 here are what your problems are going to look like at the end of completing the square. So you're not going to have any homework that looks like these 3. But again, this is the last step in the process of completing the square. So I wanted to practice it before we started. Okay. So it says, notice from example 1, part D through F, that if we write a quadratic equation so that one side is the square of a binomial, we can solve by using the square root property. To write the square of a binomial, we write perfect square trinomials. Remember me saying constantly, annoyingly, these are going to come back up? They're up. It says, recall that a perfect square trinomial is a trinomial that can be factored into 2 identical binomial factors, right? So we had x squared plus 8x plus 16. So we go into our x. My a times c is 16. My b term is 8. What adds up to 8 and multiplies to ac was 4 and 4. And so we wrote that as x plus 4 quantity squared. The whole goal of completing the square is we're going to have this portion here, this x squared plus 8x, and I've got to figure out what can I add to turn it into a perfect square trinomial so I can write it as something quantity squared. Okay, that's the whole goal here. And when we do that, this process of writing a quadratic equation so that one side is a perfect square trinomial, that is called completing the square. So like I said, we're going to be given this portion here, and I've got to figure out what to add in there to make it that. So this first part here says, before we start solving quadratics by completing the square, let's just practice forming perfect square trinomials. So your homework here is only 8 problems. The first 4 problems is just simply writing your perfect square trinomial. And so down here we have the steps on how to complete the square. I am only focusing on steps 3 and 4, and that's the writing the perfect square trinomial and then writing it in factored form. So Step 3 is to complete the square for the resulting binomial by adding the square of half the coefficient of x to both sides of the equation. That's really wordy. That sounds confusing. So let's make that into a formula. How you do step 3 is you take whatever your b term is. Let me see if I can write that a little smaller. You're going to take your b term. That's not any smaller. Take your b term, divide it by 2. Okay, that's what half of the coefficient of x is. And then we need to square it. So I'm going to take this quantity squared. And then step 4, factor the resulting perfect square trinomial and write it as a square of binomial. So then we're going to have it in this form here, and I need to write it in its factored form. So this is from your homework. This is number 1 and number 4, but 1 through 4 is going to be similar to these. So 1 says add the proper constant to the binomial so that the resulting trinomial is a perfect square, then factor the trinomial. So we have m squared minus 2m plus blank. So what do I need to add to this right here to make it a perfect square trinomial? Use your formula. This is my b. So if my b is -2, use your formula of b over 2 quantity squared. So that means I've got -2 over 2 quantity squared. -2 divided by 2 is -1. And -1 times -1 is +1. Okay, so that's what we're adding to that to make it a perfect square trinomial. So now what does this factor to be? We'll take this trinomial and factor it. So my a times c is 1. My b term is -2. So what adds up to -2 and multiplies to a +1, and that's -1 and -1. And you'll notice that it will always be what's in your parentheses before you square it. So this will factor to m minus 1 quantity squared. Okay, let's try this again. Determine the number that should be added to complete the square of the expression and factor the expression. So I've got x squared plus 8. Okay, so my b here is 8. So use your formula of b over 2 quantity squared. So you've got 8 over 2 quantity squared. 8 divided by 2 is 4, and 4 squared is 16. So I've got x squared plus 8x plus 16. It says don't factor, it wants that trinomial. Now factor it. So my a times c is 16. My b term is 8. What adds up to 8 and multiplies to 16? And that's 4 and 4. So this becomes x plus 4 quantity squared. And again, if you notice, it's the number right before we squared it. Okay, that's how it's always going to end up. Okay, so we've done all of these different parts to completing the square. Now let's actually complete the square. So here are our steps. We're going to do 4 examples. Okay. Step 1 If the coefficient of x squared is 1, go to step 2. Otherwise, divide both sides of the equation by the coefficient of 2. Part 1 is going to make the coefficient always be 1. Part 2, your homework 10, is going to go into when this does not equal 1. So for us today, we are going to always go to step 2. Again, we're going to deal with step 1 next homework, but we're going to do it differently than what they say to do here. So then step 2 is to isolate all variable terms on one side of the equation. Basically, it wants it to look like this. So when we're factoring, when we're doing quadratic formula, we always want a squared plus bx plus c equals 0, right? We want everything to one side, nothing on the other side. That's different with completing the square. Now I want ax squared plus bx equals c. We want variables on one side, your constant on the other side. Okay, so a and b, that's what we're looking for. So then step 3 and 4 is what we just practiced. Step 3, complete the, well, we already did that. This is your b squared, or b divided by 2 quantity squared. Step 4 is factor the resulting perfect square trinomial. So we're going to have x plus a number quantity squared, or x minus a number quantity squared. And then step 5, use the square root property to solve for x. That was the first examples we did. So, example 2, solve the equation by completing the square, simplify your answer. Even if it doesn't say simplify your answer, anytime you can, just get in the habit of doing it. So, x squared plus 2x plus 4, it's already in the correct form, so we're on step 3. So I've got x squared plus 2x plus something. I need to add something here. Equals 4. And notice that it says right here, we need to add something to both sides. What you do to one side of the equation, you have to what? Do to the other. So if I'm adding a number in on this side, then I've got to add that same number to this side as well. In this problem here, my b is 2. So I've got 2 divided by 2 quantity squared. That's this portion right here. This tells me what to add. So 2 divided by 2 is 1. 1 squared is 1. So I'm adding 1 to both sides of the equation. You've got to keep your equation balanced. So then step 4, factor. So what adds up to 1, what multiplies to 1 and adds up to 2? That's 1. Okay, whatever this inside portion is, that's what's going to end up going in here. So you've got x plus 1 quantity squared equals what? 1 plus 4 gives me 5. And now, step 5, use that square root property. So your square term is isolated, and that's always going to happen. So now, take the square root of both sides. This becomes x plus 1 equals plus or minus, 5 is a prime number, so square root 5. And then subtract 1 from both sides. So I'm going to get x equals negative 1 plus or minus square root 5. right? And just to clarify, remember that square tells me how many answers? This tells me my two different answers. That's -1 plus square root 5 and -1 minus square root 5. So that's your first and second answer wrote one way. Now, just to kind of tell you, I told you we're taking this a step further than what you're going to be doing when you're using this in the conic section. You're going to be stopping right here at this portion here. So just kind of keep that in mind that we're taking this a step further than you need to. But this way you get the process when you get to that conic section. So just keep that in mind. Same thing on B. It's in the correct form. You've got your variables on one side, your constant on the other. So we've got x squared plus 4x plus something equals 3 plus that same something. So my B is 4. So in step 3, use your formula. We've got 4 divided by 2 quantity squared. 4 divided by 2 is 2. 2 squared is 4. So I'm adding in 4 to both sides. So factor the left side, simplify the right side. What does this factor to be? Well, what multiplies to 4 and also adds up to 4? And that's 2. So we got x plus 2 quantity squared. And again, that's what we have right here in parentheses, right? 4 divided by 2. And then we got 3 plus 4 to give us 7. This is, again, where you are going to be stopping during the conic sections. But for the purpose of the homework, we need to know how to actually solve this. So now your square term's isolated, so take the square root. We're using the square root property. So this is x plus 2 equals plus or minus, 7's a prime number as well, so square root 7. And then your last step is to subtract the 2. So we get x equals -2 plus or minus the square root of 7 as your two answers. Okay, 2 more examples, and they're pretty much the same, but we do have one extra step on both of these. Both of these aren't in the correct form. So in step 2, we need to isolate all variable terms to one side of the equation. So I want these on the same side. That means I need to move that 1 over. So how do you move that 1 over? Well, the opposite of adding 1 is to subtract 1. So this is x squared minus 10x plus something equals -1 plus something. So how do we figure out what to add to both sides? Use your formula. We got my b right here is -10. So -10 divided by 2 quantity squared. -10 divided by 2 is 5. 5 squared is 25. This is always going to be positive because we're doing quantity squared. So factor the left, simplify the right. What multiplies to a positive 25 and adds up to a -10? And that's going to be -5 and -5. And again, that's what you have here in parentheses, right? -10 divided by 2 is -5. So I've got x minus 5 quantity squared equals 24. Use your square root property. Okay, and again, this is where you're going to be stopping during the conic section. So that's really as far as you need to go, but your homework wants you to solve this. So take the square root, x minus 5 equals plus or minus the biggest perfect square that goes into 24 is 4, right? We got to simplify our answer. So I've got x minus 5 equals plus or minus 2 square root 6. And then add your 5 over. So I've got x equals 5 plus or minus 2 square root 6. And then our last one. We need to isolate our variables and get our constant to the other side. So the opposite of a minus 20 is a plus 20. So I'm going to have x minus x squared minus 8x plus something equals 20 plus something. Use your formula. My b is negative 8. So I've got negative 8 over 2 quantity squared. Negative 8 divided by 2 is negative 4. Negative 4 squared is a positive 16. So now factor the left, simplify the right. So what adds up to what multiplies to 16, a positive 16, but adds up to a negative 8, and that is negative 4, negative 4. And again, that's what's in here in parentheses. Negative 8 divided by 2 is negative 4. So I've got x minus 4 quantity squared equals 20 plus 16 gives me 36. This is where you're stopping during the conic section, right? This is all you've got to do. But for my homework, you got to solve for x. So let's use the square root property. So x plus 4 equals plus or minus the square root of 36 comes out nicely to 6. So my last step is to add my 4 over. So I've got x equals 4 plus or minus 6. Now when you get an answer like this, if you don't have a radical in it, you need to give me the two answers. So 4 plus 6 gives me 10, and 4 minus 6 gives me negative 2. When this happens, when you don't have a radical in here, this means we could have technically solved by factoring. If you just look at this original one here, your a times c is negative 20, your b is negative 8. What adds up to 8 and multiplies to 20 is negative 10 and 2. And so you would have had x minus 10 equals 0 to get x equals 10, and x plus 2 equals 0 to get x equals negative 2. So this is another one that could have been solved by factoring. If you don't get radicals, you could have done it that way. Okay,